Okay, now let's turn our attention to budgeting. Okay, but um, so we have costs associated with each activity, and we want to look at what will be the total fund outlay week after week during the course of the project start to finish. Okay, and basically we can look at this as a four-step process. So we need to identify for each activity, look at all the costs associated with that activity in terms of labor hours, equipment, materials, and everything. Okay, direct costs associated with each of those activities. Then add up all those activities, and what you get is the cost for that activity, that one given activity. And that activity may take 3 weeks, 4 weeks, 5 weeks, whatever the duration may be. You have one cost associated with that activity. So normally, if you have a really large project, one may combine a group of activities into what is called a work package, into a larger work package, and that whole package will be considered as a single activity. I'm using air quotes here, single activity. So logical collection of activities. But in our example, so it's a small example, so we will consider each activity individually. Then the next step is to convert the cost that we have determined into cost per time period. So usually week. So if the project is monitored on a weekly basis, so suppose if the budgeted cost is 5,000 and if it takes 5 weeks, then each week we need $1,000 for that activity. So we're going to assume a uniform rate or linear in terms of budgeting. That may not be the case always, because sometimes all the cost may occur in the very first period and then there will only be labor, for example. So the uniformity of distributing the cost over the entire duration of the activity, okay, may not be valid. So in which case we have to do some fine tuning. But for our purposes, we're going to assume that there is linearity in terms of distributing the total cost into individual weeks. And then we can use the earliest start times and the latest start times to distribute when the funds will be needed. Okay, and then we can set up two charts, one for earliest start times and then one for latest start time. So let's look at the example. Okay. So we have activities A through H. So we have activities A through H. Copy paste that here. Okay. And then we are given budget. Okay, so these are given, so it comes from here, the budget. Now for each of these activities, we have already developed the earliest schedule and the latest schedule. So the earliest start time, okay, so here we have that in a table. There's a reason why we needed to do this in a table form. So earliest start time for activity A, right? Then latest start time, so that's there. So latest start time for activity A. And then of course we need the expected time. We have that calculated right there. Okay, so now we copy that. So all right, so we have the budget. Now if you take the budget amount and divide by the expected time, that will give us how much money will be needed each week the activity is being performed. Okay, now this is where okay, so we are basically assuming here that the cost will be evenly distributed throughout the duration of the activity. Okay, all right, so now we're going to distribute this activity, this cost into the weeks. So we have weeks going through 1 through 15. The project lasts 1 through 15, and we want to distribute the earliest, based on the earliest time, we will prepare one table, and based on the latest time, we'll create a second table. So the first table would be, okay, we are starting in time 0. So time 0 for activity A, time 0 means it is week 1, right? So week 1 starts at time instant 0, and time instant t equal to 1, it ends. And that period, so here this ES and LS are instants in time, and these are buckets of time. So you have to be very careful with this. So this is week 1. So this 11,000 will go to these 2 weeks because its duration is 2 weeks. It should go like that. For B, 10,000 should go from here to these 3 weeks. So you may be tempted to copy paste these into these, and that's not a good thing. You have to set up one formula, and you should be able to copy it to all the rest of the cells, and then that one formula should give us the correct amounts. So what we have to do is to check whether this week is within the start time and end time. Okay, so this is a start time, okay, or start week. So start week would be that time plus 1. Okay, because this is instant in time. So this instant in time refers to a time bucket that is that number plus 1. Okay, and then that number plus that would be the end week, end time bucket. Okay, now if this number is within that, okay, so there will be 2 conditions we have to check. Whether this week number is greater than or equal to the beginning time bucket or less than or equal to the ending time bucket, then that should be the cost. So we do if, and when you have multiple conditions like this, 2 conditions, we use and it starts with in a parenthesis, and within the parenthesis you can list all your conditions with commas. So that week, so now we need to be able to copy that across the different columns, in which case I6 should change to J6, J6 should change to K6, and so on. But when you copy it down, the week number should always come from row 6. So we have to absolute reference this like that. Okay, no dollar for I, but a dollar for 6. So this will then bring the week number always from week 6. Is that week, right, greater than or equal to the beginning time bucket? So beginning time bucket is the earliest start time. The earliest start time should be, again, always come from that column C as you copy. But when you copy down, the row should change. So this time the dollar sign should be for C and not for 7. And remember, that is an instant in time. So to get the time bucket, you have to add 1 to it. Okay, so that's your first condition. The second condition, so comma, the second condition is that week number, once again, make sure that it is $6, right, is less than or equal to, okay, the earliest start time again, once again, this time the dollar should be for C plus T, and that should be again always from column E. Okay, now finish the first parenthesis. So that was your AND condition. Are these 2 conditions true? If these 2 conditions are true, then the cost per week, and once again that should always come from column G. So it should be like that. So that would have to be displayed in that cell. Otherwise, it is 0. Okay, so now that formula, okay, Okay, let's make that into a currency like that. So now if we copy down, okay, you see, and then copy across. All right. So 2 weeks, starting from week 1, 3 weeks, and then on and so on. So now we have the earliest, the fund requirement based on earliest time. Okay. So weekly need, how much do we need on a weekly basis? Okay. So if you sum across the column, then in week 1 we need 21,000. In week 2 we need whatever. Okay. So this will be for each week how much we need. And then total till week would be a cumulative value. So that would be the sum of, okay, I5. Let's make that absolute reference. Okay, so that first I15, okay, the first I15 should be absolute referenced. The second should be floating. So when you copy, you'll always sum from here up to whatever column that is, okay, that's copied over. Okay, so this is our funds layout, okay, based on the earliest schedule.